This lecture focuses on training a convolutional neural network, or convnet, from scratch when you have a limited amount of data. Even with small data sets, deep learning can often outperform traditional machine learning methods on complex image tasks by automatically learning hierarchical features directly from the data. For this lecture, we will use a small image dataset available in scikit-learn. We start by loading the digits dataset using load_digits from sklearn.dataset. Then, we display some sample images from the dataset using matplotlib to visualize what we are working with. We also print the number of samples and the image shape to understand the dataset's dimensions. Next, we move on to building our network. We will build a simple convnet model using Keras. The model consists of convolutional layers to detect features, pooling layers to reduce spatial dimensions, activation functions like ReLU to introduce nonlinearity, a flatten layer to convert 2D feature maps to a 1D vector, and dense layers for classification. We define the model using keras.sequential and add these layers. We then compile the model using the atom optimizer and sparse categorical cross-entropy loss and display the model summary to see the layers and parameters. Before training, we need to pre-process the data. Convnets expect input in the shape of height, width, and channels. Our images are 8 by 8 and grayscale, so they have one channel. We reshape the images using reshape to include the channel dimension. We also normalize the pixel values by scaling them to a range between 0 and 1 by dividing by the maximum pixel value, which is 15. Finally, we split the data into training and testing sets using train test split from sklearn.model_selection with a test size of 20%. Data augmentation is a crucial technique for training deep learning models on small data sets. It involves creating new training examples by applying random transformations to the existing images. We create a data augmentation generator using image data generator from tensorflow.keras.preprocessing.image. We configure it with parameters for random rotation, zooming, and shifting. We then fit the generator on the training data using datagen_do_fit. This generator can then be used during training to augment the data on the fly. In conclusion, this notebook explored how to train a convnet from scratch on a small data set. We used the scikit-learn digits dataset, built a simple convnet model, pre-processed the data by reshaping and normalizing it, and used data augmentation to increase the size and diversity of the training data. These techniques are essential for achieving good performance when training deep learning models on limited data.